So officially welcome. My name is Alethia O'Hara Stephenson, a president and founder of the Dufferin County Canadian Black Association, DCCBA. DCCBA was an organization that was established to lead, advocate, and empower our Black communities in Dufferin County. We have a strong focus on youth achievement and excellence. Tonight, our session is on machine learning and AI, artificial intelligence, one of my favorite subjects, simply because it's an avenue, it's a subject that I don't know enough about, and there's so many cool and exciting things to learn. So our speaker or expert tonight, his name is Sem Onyalo, and I'm going to take the time to read his bio because it is pretty impressive. So Sem is a data and machine learning architect working at a consulting firm in Toronto. He has over 10 years of experience delivering modern enterprise solutions in a variety of industries. Sam specializes in building machine learning pipelines in the cloud and computer vision deep learning applications. He is a computer systems engineering graduate from Carleton University in Ottawa. Sam got into engineering because he read stories about Black inventors when he was a child and is passionate about bringing up the next group of young Black inventors after him. So pretty impressive bio. Thank you so much, Sam, for saying yes to be one of our experts and for sharing your knowledge and your expertise with us. As people join the session later, we'll invite them on to ask any questions that they may have. So take it away. And again, the session is being recorded and we will be sharing this with our network after tonight's event. So thank you once again. Welcome.
Great. So yeah, thank you, Alethia, and thank you for inviting me to this and having me here. So like Alethia was saying, yeah, this presentation is really just about in general, Black youth in AI, but getting more of our youth into advanced technology fields. So I want to start off with a little icebreaker before I get going. I don't know if anybody here is a fan of hip hop music, but if you are, these people should not be strangers to you. This song, Still Dre, is a pretty old song now. I don't want to expose probably exposing my age now, but this song, Still Dre, was performed by Dr. Dre and Snoop Dogg, and there was one other person who was involved in that song, which you may or may not know. And so I'll leave it there for now. I'll jump into who I am, and then we'll come back and see if anybody can solve that riddle. Right, so who am I? So as Alethia was saying, my name is Sem Onyalo. I'm a data / ML architect. I work at a consulting firm, and I have essentially 12 years of experience in a variety of technologies and applications, the most prevalent of which are computer vision, graph databases, big data pipelines, and web and API applications. Don't worry if you don't know what any of that means, that's okay. There's not going to be a test after this. Really just a broad overview of the example of the experience that I have. So that's what I do during the day. And then in my spare time, I'm a deep learning hobbyist. I build different projects. That's one project that I built there, showcased with the mask on, mask off, that I built for a healthcare company who was looking for different ways that computer vision could be applied in their industry during the pandemic. And of course, the pandemic was the top of the news and everyone was talking about it. So it was easy to sort of use the mask mandates and the whole conversation around masks to build a simple application around that. And so I've been posting on social media for about 4 years now on various like YouTube, writing blogs on Medium, posting code on GitHub. If you search for me, you probably will not find me. I'm definitely not a big, influencer, as they say. Really, is just a way to sort of put myself out there, just sort of, find like-minded people who are also interested in the stuff that I build. I am a quintessential nerd, so very used to being in the background, but just a different way to sort of expand my horizons and meet like-minded people, and like this presentation is about really trying to then move the needle forward and bring the next generation of Black youth up into advanced fields, and particularly AI. Okay, so now that that's out of the way, I'm not a huge fan of talking about myself, but let's get back to the icebreaker. So I don't know if I can't really see in the chat, but if anybody wants to take a stab at who might be the third unknown person who is related to that Still Dre song. And I'll give you a little hint just in case. Actually, no, sorry, I won't give you a hint. Jumping ahead. Anybody have any ideas?
Give us a few seconds, and we're going to try and solve it. So.
Sure.
What is it?
I put Jay-Z, but I'm not sure if that's accurate, but I took a stab at it.
Yeah, no, that's perfect. That's the answer is Jay-Z. So I'm glad. So I was hoping that at least one person would not leave me hanging, and so that was awesome. So this is more than just an icebreaker. This is actually is a segue into what this presentation is about, and just to sort of take a step forward, if I swap these around, so we take Still Dre and we take out Dr. Dre and Snoop Dogg, we're left with Jay-Z. And I don't know if that sort of format is familiar to anybody, but if you have been in the math world or the science world, you would recognize that as algebra. And so the reason why I bring this up and the reason why I presented it this way is because I came across an interview from a radio show called The Breakfast Club that I'm a fan of. And one of the hosts on that show said that he understands math until you introduce letters, and then he gets completely confused. And when I saw that, it reminded me of stories that I heard when I was younger, where a lot of our youth will get dismissed in terms of not knowing something or not being smart enough, simply because they don't grasp certain concepts. And in my mind, I know that that's and I mean, I'm sure a lot of people know that as well, is that's sort of that's not completely accurate, right? There are ways that you can present certain ideas that work, as long as if you present it in a way where the young people can relate to. And so in this case, if we're talking about algebra, if you present it as something that the youth are interested in, say for example hip hop, and like I said, I'm sort of showing my age here. I'm sure the younger people would probably use a whole different set of artists. But the point is that if you frame the problem differently, you're able to capture youth that you might not be able to capture in sort of a traditional setting, or how things have been done in a traditional way. And so with that, I'm going to jump into my agenda, or the agenda for this presentation. And so I've mentioned before, and I'll probably keep iterating and keep repeating this, but the goal is really just presenting, really trying to get more of our youth into advanced technology fields. And I'll hit on why I think that's very important at the end of the presentation. But that's really the main goal of this presentation. And the audience is educators, parents, and young people. I don't know if there's any young people watching this. I know how young people can be. I used to be young as well, but I mean, I guess we all used to be young, so we know. But definitely, for sure, educators and parents, if maybe you struggling to figure out how to get young your children or your students into a field like deep learning, which is obviously just growing at an exponential rate. Hopefully this can help and give you some ideas. And so I'm going to be talking specifically about deep learning. And again, if you don't know what that means, I'm going to go into that in a second. And I want to talk about my specific story, which hopefully gives some context to how I got into deep learning. And then I'll go into a path, so a general path of how others might also get into deep learning. Okay, so what is deep learning? Again, don't worry, I'm not going to go deep into the math, so don't get scared. But it does help to sort of give some context into sort of what I'm talking about. So I'm sure you may not have heard of deep learning, but I'm pretty sure all of us have heard of artificial intelligence, or AI. And so AI at a very high level, and it's very broad, but what AI is a technique that enables machines to mimic intelligent behavior. And I know in our current state of world, intelligent behavior is relative, but humans are generally intelligent, and we can build machines to mimic that behavior. And really, it comes down to making decisions and that sort of thing. And so that is a very broad term. There are a lot of things that fit within the artificial intelligence bubble, but specifically, as we sort of zoom in to one level, we get into machine learning. And so machine learning is specifically a technique used to enable machines to learn. And so what that means is you're building a machine to learn based on information that you're giving it. So the perfect example, which I used before, if you saw the mask, no mask image that I showed previously, that machine was taught to learn or make decisions based on what it was fed in terms of if a person was wearing a mask and if a person was not wearing a mask. And so that's like a subset of artificial intelligence. And so if we go one step, sorry, I see a hand up.
Yes, Sam, I'm just curious. So when you're doing machine learning, is there some sort of a balance that, I guess, validates the information that you're putting into the machine? Because essentially, if a human is feeding the machine with codes or rules, then that could potentially taint the output of whatever that machine is learning. Can you speak to that?
Yeah, absolutely. So that is very true. The machine learning model, which is what we call the thing that you're training, right, is highly dependent on the data that you give it. So if you give it bad data, bad data in, bad data out, right? So if you give it bad data, its predictions will be bad. If you give it biased data, then its predictions will be biased. And that's actually a great question, because that directly feeds into why this presentation exists in the first place. And so I'll leave it there and then jump back into that at the end of the presentation.
Perfect.
But yeah, great question. Right, okay. And then so if we zoom in one more level and we get to now finally deep learning. And so deep learning is a subset of machine learning. And the difference between deep learning and machine learning is deep learning is built, still building a machine to learn, but now we're using something called artificial neural networks. So an artificial neural network is just an artificial brain, so to speak. So mimicking the neurons in a human's brain. And then what that allows you to do is build a machine learning model that is able to learn vast amounts of information, and so a way more amount of data than you could with machine learning, and the accuracy is way higher. So if you were to compare a machine learning model, you say it would, if you gave a machine learning model and a deep learning model the same test with the same data, the machine learning model might take maybe 2 years and get 60% on the test. An equivalent deep learning model would probably take maybe 2 months, and it would get 98% on that test. So hopefully that shows how much of a leap deep learning is compared to machine learning. And on top of that, machine learning, there's a lot of manual tweaking. Like if you remember the olden days where you had the operators plugging in and out those, whatever, I don't even know what they're called anymore, that's so long ago, but that's essentially, it's very manual process machine learning, whereas deep learning is a lot more automated. And so now to bring it back to full circle, if we're within the context of deep learning, machine learning, and AI, there are different verticals. And so computer vision is one vertical within that ecosystem. And so that computer vision model was a deep learning model built to detect whether a person has a mask on or whether they have a mask off. Okay. So yeah, so now hopefully we have a good understanding of what deep learning is generally. And now, so I'll get into my specific path and how I got into deep learning. So that's me, senior kindergarten. Very much, like I said, I was very much a nerd from the jump, very early. Actually, my mom dressed me there, so you know, speak for that what it might be. But I had an affinity for math and science and for building things. So from an early age, I was really into you know, math, computers, that sort of thing. And so my mom, noticing that, was very good at providing different, you know, toys and activities to help nurture those talents. So, for example, she used to buy me chemistry sets, Legos. Everyone knows about Legos. She bought me that as well. She didn't buy me a computer. Like back then, computers were like, it was like buying a small car, but I did get to play with the computer. And so those were the things that sort of nurtured that interest that I had and that affinity for, you know, math and science that I had, which was sort of the first stepping stone into what would later become a deep passion for deep learning, no pun intended. And then the second part of that was what is essentially a book on Black inventors. Now this isn't the actual book that my mom bought. I can't actually find it. One day I'm gonna have to go back to my parents' house and, you know, dig through the crates and figure out the actual book that I got. But this was a very poignant moment in my life, because I remember after reading this book about Black inventors, deciding that at that point that's what I wanted to do, and I wanted to be an inventor. And you know, probably preaching to the choir here, but you know, representation matters. And you know, it's hard to see yourself in a position unless you see other people like you in that same position. So really the combination of my mom sort of nurturing, you know, those sort of, that affinity that I had, combined with that book that she bought me, which allowed me to sort of see other people who also had similar interests as me, was really sort of that foundation that led me onto, you know, the path that I'm on now. And so fast forward, you know, continuing to build projects on the side all throughout, you know, high school, which led me to Carleton University, which Alethia mentioned before. And the important point here is that high school, you know, kind of got into a little bit of trouble. I won't say specifically because, you know, the aunties are listening, so won't get into specifics. But I did get into a little bit of trouble during high school, as you know, some kids usually do. But very early on, my parents sort of stressed the importance of education, and specifically higher education. And so there was a point at which I probably grade 10 or 11, where it was a trigger in my mind where I was like, okay, if I don't, you know, shape up, I'm not going to be able to, I don't have the marks to get into the university and to get into the program that I want to, because I already knew I wanted to do engineering. And so that, that sort of seed that my parents implanted in me early on, even though, you know, it may have seemed that sort of I had gone off the rails, was still there. And so it kind of popped up, you know, when, you know, it needed to matter. And so I sort of, you know, shaped up, got my marks back up to where they needed to be, and eventually got into to university. And then from there, I went into industry. And then, like I was saying before, did a plethora of different technology databases, and 12 years of that, and that's where I am now. So, I wanted to definitely get through that, but I think I really wanted to sort of pause here and just take a moment to stress the importance of providing a general path to deep learning. So, I think it's important to tell my story because, it gives context, but I really want this to be a session where I'm providing sort of examples and action items that maybe, people can take or provide to some young people to also help them. Because again, it's really about helping to get the next generation. It's paying it forward is essentially what this is, and trying to get provide tools so that hopefully you can get ideas to provide tools for the next generation to also get into fields like deep learning. So the first thing that I really want to stress before I sort of get into the specifics is the programming versus problem solving. And so if you're not in technology, you may be not, you may have like a misconception in terms of like what coding is, what problem solving is, what deep learning is. So just to give context, so my first programming course in university, which happened to be C++. So if you see the C++, which is just a programming language. The first programming course that I took was not called C++ 101. It was called Problem Solving 101. And that was intentional because what you find is that sort of the best practitioners of tech in general are not people who know specific languages. The language. And so right now there's definitely a push for learning languages, and I think that's fine, but I think it's important to stress that the goal is to stress the problem solving piece of it, not learning the specific syntax of a specific language. So for example, all of these languages here, like I know all of these languages can sort of like flip between one and the other and others. And the reason why I'm able to do that, and the reason why I was able to move from software application development to data engineering to machine learning to deep learning was because I had a foundation of problem solving as opposed to a specific programming language, information or knowledge. So now that I got that out of the way, I'll get into a specific example. So this is a, let's see. Kit using an Arduino board, so that blue computer board on the left. This would essentially be like a good entry point for kids who are interested in technology. I didn't have these boards weren't available when I was a kid, but I built similar things to this where you have electronics, you have something that you can build, you can turn it on, it moves around your room. So what this does is it gives you an entry point in terms of building problem solving, but it also allows you to extend beyond the actual kit. So for example, this board that you see here, it's running open source software, which means that you can update it as you see fit. An example would be maybe you wanted to add some custom LEDs, maybe you wanted to control the robot car with your phone as opposed to the RC controller that it comes with. The examples are pretty endless, right? Good entry point into the world of technology, the world of STEM, the world of which eventually could lead to the higher advanced fields like deep learning and that sort of thing. Okay, so next, this is an example of an entry-level machine learning problem. So this is an application that I built using something called OpenCV. OpenCV is, again, another open source computer vision library. And TensorFlow is it's a machine learning library, which isn't necessarily important other than it's the thing that's tracking the orange on the screen. And so if you remember previously, there was, I had that image of the mask on and mask off. So think of like, taking a cereal box off the shelf and like, using it right away. This is essentially a model that was pre-built to detect a whole bunch of different objects. This one being, in case an orange. So I, picked an orange from the fridge, built a little application around it. And then, this was built on my laptop and then sort of took a video of what that would look like. So it is a bit of a jump from the STEM build kits, but not that crazy of a jump if once you get into like a little bit of programming, a little bit of problem solving. This isn't like too high of a step, and essentially it's an example of some basic machine learning with, you don't have to know the math or the calculus behind what's going on in machine learning or deep learning. It's really just a few plug and play options that you can put together fairly quickly to build something pretty cool. And then next, I'll jump to, so now this is, let's say gamification. So this is an extension of the previous video. So this is, if you remember, the previous video was an orange being detected on a screen using a pre-built model off the shelf. This is taking that one step further and training your own model using red and blue balls and creating a game out of that. So let me just play this just to give you an idea of what's going on here. So this is essentially a two-player game put together just to test, really just an extension of the orange detection that to show that deep learning doesn't always have to be about math and science. It doesn't have to be it can be fun, right? I brought this game to a maker fair. Set up the laptop and a screen and just put, those two balls and those sticks on the table. And then the kids just picked it up and they started playing around, right? And from that, that's when the questions came. It's like, oh, how did you build that? How is the ball being detected? What is that yellow box? How are you, mapping or matching the ball to the box? And there's a great quote by a man named Jeremy Howard, who builds courses in AI. And he essentially says is like, when you learn to throw a ball, you don't sit down and start learning the physics of how a ball moves through the air, right? You go to the park, you pick up a ball and you start throwing it, right? And similar to that, you can do the same thing in the field of artificial intelligence and deep learning, right? It's, you can play around with spawns the ideas of building different things. So gamification is really a great way to introduce kids to artificial intelligence and specifically deep learning and computer vision. Okay, and then so again, this is another extension of the previous game. This is based on, again, so instead of detecting red and blue sports balls, now it's detecting boxing gloves. And so the general idea is the same. It's a target game, but now extended to be boxing gloves and with specific specific punches specific to boxing, if you're familiar with boxing technique. So the reason why I bring this up now is because people learn, and especially me, I learn from thing, right? So I happen to be interested in boxing, so I built a boxing target game out of what I had learned in terms of like computer vision and that sort of thing. You can do a similar thing for like if you're into soccer. There's really no difference between this and training a model to detect a soccer ball. Trying to place the soccer ball in a specific area of the screen if you're juggling it. Basketball, same thing, dribbling the ball in specific areas of the screen, trying to place it in the target on the screen. The possibilities are really endless, not to use, platitudes or anything, but the possibilities are really limited based on like what the person is interested in, right? So whether it's, boxing, basketball, soccer, I mean, there's so many different ways that you can, build an AI application, and the foundation from this is what you're interested in or what the person is interested in, and then using that as sort of a stepping stone to get into the AI field and deep learning and computer vision and that sort of thing. Yes, question.
This is so exciting. I can't wait until the end to ask my questions. I have to get them all now. So I'm looking at your boxing model here, and can this model essentially be used for coaches to optimize an athlete's performance? So what you're showing me here is you're detecting the different options, whether it's a jab or a cross punch, etc. But can it optimize the athlete to say, your body is not in the right position. If you position your body this way, then you'll get, better performance. Is it able to do something like that?
Yeah, absolutely. So, this specific application, because it's focused on the boxing glove, but what you're talking about is very possible. There's another technology called pose estimation, which can basically track the position of your body, where your head is, where your arms are, that sort of thing. And so it's definitely possible to build, to incorporate this into, say, like a coaching, training regime or regimen, for example. I remember actually I spoke to a couple of boxing coaches about this, just to, get some ideas. So yeah, what you're saying is definitely possible. And that's one of the other great things about things like this, especially if you start with what you're interested in. There are a lot of, whether it be, opportunities in consulting sort of skills, but even opportunities in like startups and business and that sort of thing, where the business ecosystem for things like computer vision, for things like deep learning is really like open. And so to your question, in terms of like for like coaches, optimizing body position, you can even optimize sort of speed, track like how fast you're able to switch between punches, how fast your adaptation skills are, when you're not expecting which punch is going to come next. There's a lot of definitely possibilities for that, for sure.
Perfect, thank you.
Absolutely. So what a moonshot project is an ambitious project that is just out of reach of what your capabilities are, right? So it's not so out of reach that it feels impossible, but it is out of reach enough where there is some work involved in like figuring out how you're going to build it. And so the best example of that would be, I think JFK, when he, John F. Kennedy, when he said that thing about putting a man on the moon within the next decade or something like that, right? So that's an example of a moonshot project. Google has a whole division dedicated to moonshot projects, and what that does is it really gets the juices flowing, inspires innovation and invention. It really pushes, people forward to learn new things and build what they're really interested in. And so it's really important to really define, moonshot projects, and it's whether you define it for a group of people or whether people define it for themselves is really up to the person and the individual. But it's really a way to sort of push individuals to really push past their boundaries, the same way like you would push past your boundaries in like a workout, right? You're gonna do one day you do 5 push-ups and you fail at 4. Then you can do 5, then you try and get to 10, and you can only do 8. It's a very similar process in technology, right? You define a goal that you you can build, but you're not quite sure how you do it. It takes a little bit of learning, a little bit of experimentation, a little bit of trial and error, and that's really an important driver in how to get people in general, but especially young people motivated to learning, these advanced technologies. And again, it doesn't have to start with, calculus and algebra and, matrix multiplication. It can start with the passion and the drive for building something cool. Okay, and so that is, hopefully that provides a good sort of foundation in terms of, or at least ideas in terms of what, might work for a particular, young person, and, in terms of, how to get young people interested into AI, getting them building different things, getting their juices flowing, the ideas flowing. But I did want to end on a very important note, and not to make it too ominous, but this is a screenshot of an article, and there are many articles like this, of how AI, in particular deep learning, is being integrated into our society. And so currently there are, and this actually speaks exactly to what Alethia was asking about, feeding in data, especially bias data. So there are models right now that are being utilized in government agencies, law enforcement agencies, which are biased towards people of color, right? So there have been different people who have noticed that models that have been released by big tech companies tend to label erroneously, say, Black faces, right? So say like two Black faces look alike, even though they're not the same person, right? And so and these tech companies are sort of aware of these issues, but even though they're aware of these issues, that doesn't stop law enforcement from actually utilizing these and implementing them in their sort of day-to-day operations. So I think that not only is it it would be cool and important, for our youth, specifically Black youth, to sort of get into these fields. It's actually imperative because these technologies are being used, and it's only when we're in these spaces where these models are being created where we can actually point out the biases that we see early on before they get implemented by law enforcement agencies, government agencies, which are sort of utilizing these models in their day-to-day operations. And so it does matter when we are in the room. And the only way to sort of get us into the room and, to prevent things like, for example, mass incarceration, like, that's happened in the past, is to sort of get more young people into these fields, into these spaces, because again, it's being used right now, and decisions and, lives are depending on models that are being used right now, which are being trained with biased data. So don't want to sort of end on a bad note, but it is, I think, important to call out that it's not just cool, but it's also imperative. Sorry, question?
Steve, go ahead. You have your hand raised.
Yeah, maybe if you could take the end of the presentation so I could see. Maybe, is it Sam?
Yeah, this is the final piece. So go ahead.
Okay. First of all, I want to say that even though I joined a bit late, I found this, and I was actually looking forward to this chat because this is a new space for me, and the amount that I heard was very fascinating. It's interesting that you ended on this because this really dovetailed nicely into the question I was going to ask, which is, let me start off by making the statement first. When I think about AI, I can't help, and this is going to bring a smile to your face, is I think about iRobot, right? I think about that Will Smith movie with iRobot, where as you talk about pushing boundaries, that for me, once upon a time watching that, I was thinking, man, that's, wow, like, could that actually happen? And you start to think that when you push the boundaries too much, these are some of the possible ramifications. So even though that was a movie, I guess my question is, what ethical concerns? You talked about it briefly as you ended your presentation with how this could be used to further marginalize groups. depending on how the technology is used. But as much as a cool thing to enter, what sort of ethical concerns that one should be paying attention to when diving into this space?
Yeah, no, that's a great question. And I could probably create a whole new presentation just to speak on that. But I think at a high level, and sort of to put aside the iRobot, because that, even though that isn't necessarily realistic, even though, you know, there's a lot of stuff in the news about that. I think it's more poignant about like the ethical parts that you're speaking of, and I sort of touched on that with the law enforcement. So it's really just about how models or machine learning models and AI models can affect people's lives, right? So one area is, you know, law enforcement. There are, like, for example, using AI models in agriculture, for example, and you know, I'm pretty sure, I don't know if people have heard the stories of like Monsanto, for example, whereas like what they've done in terms of you know, in the agricultural space. But essentially, at a high level, companies are utilizing AI models to increase their revenue, right? Or in the case of, like, say, government agencies or law enforcement agencies, increase, you know, arrest rates or convictions and that sort of thing. So if that happens at the expense of, you know, humanity, then that's when you start getting into ethical concerns. And so typically, if you are in a marginalized group and you're in the space where these models are being created, you can sound the alarm earlier, right? Because you're aware of that and you're part of a marginalized group. Whereas if people from marginalized groups are not in those spaces, you know, companies are going to do what companies are going to do, right? And they're going to go forward, whether it be for revenue or you know, whatever it be, political gain or conviction or whatever it happens to be. They're going to go forward with what they know and what their goals are, at the expense of the human side of things. Does that answer at least partially?
It does, and I thank you for that. I don't want to sort of hog the time, but this is really new frontier stuff for me, right? Because I remember reading an article how, as you talk about for revenue, for profit, where stores are implementing this sort of facial recognition technology, and what I think they're trying to do is try to use it to determine sort of behaviors or whatever, like when you come into the store, something along those lines. I don't know if you're aware of that. You probably are. If you maybe could speak to that, because I wonder, and they say, well, it's not an issue because you consent basically walking into that store. So they're allowed to sort of use that technology to sort of gauge your behavior or your shopping behavior so that they could target you. But it just seems that they're bringing this new technology to, I don't know, maybe it is for revenue purposes, but what are your thoughts on that?
Yeah, so again, it's like another sort of, on the surface, it's really just, you know, companies are doing that so that they can, you know, prevent theft. So on the surface, it's a very noble cause. But then if you sort of dive deeper, it's okay, well, where are they getting the data to train those models, right? And then
That's
so
right.
We know that you know, typically, you know, people from marginalized communities are the ones who are targeted unfairly in those scenarios. So are they using data where, you know, people are targeted unfairly? And so if the data that you feed in, because I think one important thing to notice is a lot of these models are labeled. So you give it data, but then you have to label that data as, like, say, X. So the same way you would say the same, like, mask, non-mask example, it would be similar things. So suspicious, not suspicious, right? And so that's a perfect example of, like, what is deemed suspicious and who is labeling that as suspicious, right? And so just based on history and based on sort of what we've already seen in, you know, models being in law enforcement, or the models being biased models being utilized in law enforcement, if the people who are, you know, making biased decisions are also labeling the data and that is biased, then what you would typically see is, maybe marginalized people being labeled as suspicious and being kicked out of that store. And on the surface, yeah, they're just trying to save money, they're trying to prevent theft, but you sort of perpetuate that same cycle, but now instead of doing it from a human perspective, you're doing it from a computer perspective. And I think it's good that you brought up iRobot, because I think that's a lot of people in the media sort of sensationalize that as like the scary thing. But I think what's more scary is that these models that are being created by human beings, and now the onus, there's a sort of a separation between the human and the machine. So, okay, no, we're not biased. The machine is biased. You can sort of, put blame on the machine. But if you sort of dig down, it's like, no, there was a human who built that machine, right? The data was collected by humans to sort of train that machine. But if those machines are being provided to sort of corporations, sort of the same way they would pick up, say, like a cloud solution, or like the same way we would pick up a car off the lot, right? Now the onus is not so much on the company, but it's now on the machine, and that's really the scary part, because then it's there's even another test that someone did where they put a picture up of two people who had committed, who had basically had similar backgrounds in terms of like getting in trouble with the law or whatever, this and that, and one happened to be a white person, one happened to be a Black person, and they ran this through this model to provide like what the appropriate sentencing would be, and the sentence that was sort of predicted for the Black person was an order of magnitude higher in terms of like how many years they should spend in jail versus the white person. So I think that is definitely the scarier part, whereas you put the onus on the computer, and then the humans can now step back and say, it wasn't me.
All right, thank you for your time. I really appreciate that, bro. Thank you.
Absolutely.
Before I jump in with my comments and questions, gonna see if there are any other questions from the chat. Melissa, thank you for joining. I don't know if you have any questions. Awesome.
I wish sorry?
Go ahead.
I wish I joined earlier, but I heard that you were from Carleton University. That was my old school there. Am I right?
Nice. Yeah, yeah.
Ottawa?
Ottawa, yeah.
Oh,
awesome.
Fabulous. I went there from 1995 to 2000. So I love that experience there.
Awesome. Yeah, no, I had a great experience there. I was kind of like in the library for most of the time, so I didn't really get to do the social things, but did get to do a little bit of that at the end of my time there. So yeah, definitely a great time.
Yes, I want to ask a question. One of my many jobs at Carleton University, because I had many, just coming from Jamaica, was like, the stereotypes of having like 3 jobs. I was exactly like that. I had probably about 3 or more jobs while I was there. But one of my jobs was a telecounselor. And that job entails me to call students that were interested in coming to Carleton, and just to follow up on them. Usually they do those, what do they call that, fairs or so, that they'll go to different high schools and introduce the schools and stuff. I forgot what it's called. But what I noticed when I was calling back these students that they had gathered the information from, is that a lot of the students wanted to get into programs like yours. However, they did not have the subjects, or didn't know that they had to have the subjects at the time. So I found that they were getting themselves in problems, because by the time we are calling them, they're supposed to be on their way to university. However, I realized that they did not have calculus, algebra, and another one, I forgot what it was, but there were like 3 core courses that you have to enter, like professions like yours, and engineering and computer. However, those students never had it, and that guidance counselors never directed them to those subjects. So that's a problem. How do we solve something like that?
So I guess I can, to speak to my experience, so the school that I went to had program, or there was a sort of a part of a course in a program where you were able to sort of pick what you were interested in, and then it would sort of say, for example, okay, I'm into math and building and that sort of thing, and so it would match that to a particular, say, course or broad industry. So for me, it happened to be like computer engineering or like mechanical engineering, and then it would then list the courses that you would need to take to then get into that course. And so I think that was in grade 10, and so maybe 9 or 10. But anyways, it was at that point where I was like, okay, I need to take calculus, and so it was sort of drawn. The line was drawn from like early on into like grade 9 and grade 10 for me. So it's hard for like I don't know like the specific scenario around why those kids didn't have that same support in terms of like picking what they wanted and then needing to or being directed to the courses that they needed. But I think that it would start, if it's possible, to introduce that. And I don't know how you would do that because I don't know that specific scenario, but it would be important to introduce something like that, say at like grade 9 or probably grade 9 actually, where it's actually might even be grade 8, but anyways, where you're able to sort of direct that in terms of the courses you take. So I don't know if I can speak beyond that because there's like guidance counselors and school systems, and I'm not good when it comes to bureaucracy and stuff, but hopefully that sort of helps. It's really just of like getting in at that early age, providing that sort of ecosystem to pick what they're interested in, and then mapping that to the courses that they need to take throughout high school. I'm not sure if I answered your question.
Yeah, so I guess they would have to introduce those subjects to the students at age, I guess not age, but grade 9, I guess. Grade 9?
Yeah, I believe grade 9 is when, so I think grade 9 and grade 10 is when everything is sort of generic and sort of everybody has to take everything. But I think when you start to get into like grade 11, that's when you start to, okay, I need to pick like, grade 11 algebra, linear algebra, calculus. I think it's definitely important, definitely by grade 10 for sure. I think grade 9 would probably be the safe bet.
Okay, good, thank you.
I think one of the things that jumped out for me, Sam, right at the beginning of the presentation was, those students who not necessarily were math inclined, but they're great problem solvers, right? And so once you're able to, break it down for students and, put actual pictures. So I think, Millicent, I'm not sure if you were on at the beginning of the call, but okay, so Sam, can you bring up that very first presentation, that very first slide with the 3 images, the C+?
Sure.
For me, that was very powerful. And I think if as educators and parents, we're able to break it down for our young people, it'll change their perspective. So perhaps you can just start from the beginning and just play that first slide or 2 slides again so that Melissa can get a chance to answer the question.
Sure. So pretend you didn't see what you just said. And so really the question here is, if you're a fan of hip hop and familiar with hip hop, you should know these people shouldn't be strangers to you. There's Snoop Dogg and Dr. Dre. They created a song called Still Dre, but there is a third person who was involved in that song, who not a lot of people are aware of. And now we're going to pretend that you didn't see the answer. I'm going to ask you who that was, and then you can say, "Oh, I don't know." And then I go, "Oh, that happened to be Jay-Z," which actually someone did get in this call. But so that was intended to be an icebreaker into the presentation, but it was also a segue into the broader sort of theme of what this presentation was supposed to be about. And so if you sort of swap the images and you say you take Still Dre, you remove Dr. Dre, and you remove Snoop Dogg, you get Jay-Z. And this sort of format that you see is essentially algebra. There is really no difference between the images that I used and using letters, right? Using letters in math is really just a way to represent an unknown. And so what I wanted to convey and was that a lot of times in our community, young people are sort of dismissed for, say, if you don't get something right away, you're dismissed as maybe you're not smart enough or maybe not good enough to understand that. But I think the point I was trying to make is these things are actually relatively simple to understand if you use concepts as opposed to like specifics, if you use concepts that young people are interested in. So I can, and don't quote me on this, but I can almost guarantee that I can go into any high school, predominantly Black high school, whether it be like lower income area. I can present this problem and pretty much teach them algebra in probably like 10 minutes. And that's because it's about using concepts that they're interested in to teach broader concepts about like algebra. So that's kind of what I was trying to convey with that icebreaker.
That's powerful. I love that. Thank you so much for sharing. We're at time. I want to give the rest of our participants a chance to ask any questions. I know we have some young ones on the line. Yes, thank you, Josh. Great presentation. I absolutely agree. So before I close, I want to just simply say, Sam, this was absolutely fantastic. I can't help but reflect on, the credit that you gave to your mom and how much she kind of nurtured you, and she saw the potential that you had, that affinity for math, and nurtured that, and went out and bought you the book on Black inventors. And so it is poignant that, we're here today and you want to be able to pay it forward. So shout out to your mom, and shout out to all the moms out there who are, instilling greatness in their young people. You touched on a number of things. One of the things I'd love to find out from you is, do you have a contact information that we can share with our audience? If you can just drop that in the chat, that would be fantastic, whether it's your email address or YouTube channel, whatever means people can get a hold of you, that would be fantastic. And last but not least, sorry, I just wanted to say simply, thank you for your time tonight. The presentation was absolutely amazing. When I look at the number of, especially our young Black youth who, are often streamlined into a certain area, whether it's just sports, whether it's music, there's so much more potential and so many more opportunities that are out there for them. So the fact that you're able to share your expertise, share your path with us tonight is absolutely amazing and inspiring. So thank you for that.
Yeah, no, thank you for having me. This is really just, like I said, pay it forward, and anywhere where I can help do that is my pleasure.
Wonderful. So if you have an affinity for math, you can do machine learning, you can do data engineering, you can be a software engineer. What else is there? What are the fields?
So many, IoT, Internet of Things. Within AI, there's swarm intelligence. There's the list goes on. There's so many different things.
Awesome. This is great. This is all new information for me, and I absolutely love it. I will definitely be sharing this information as well with my contacts in the schools, and hopefully we can get more young people engaged and exposed to the world of ML and AI. So once again, thank you. Thank you. And until next time, or next Ask the Expert series is scheduled for October. So thank you again for joining, and we will be in touch. Until next time, cheers.